For this section, the notes and the worksheet are going to be on the same page. So I don't want you grabbing the normal note sheet. You'll grab the green number 3 sheet. It's got a front that looks like this and a back side that has 4 problems on it. So I need you to pause the video and go grab 2 things actually. Go grab the green worksheet to take your notes on and go to the front table and grab one of those square pieces of cardstock. There's too much writing in this for you to have to write out all your own notes. So this one's got a template for it. So go grab those things, pause the video, and come right back and start it. All right, so we've already talked about a quadratic equation, and we've talked about what it looks like. And I'm getting the spinning wheel of doom here, so let me see. Okay, there we go. So we've got our quadratic equation, our quadratic function, and it always looks like y equals ax squared, and it's really this squaring that clues you in to the fact that you have a quadratic function and that when you graph it, it's going to make that U-shaped thing called a parabola. All right? And those parabolas, we talked about it. They open up if that lead is positive, they make a smile. They open down if that lead is negative, they make a frown. So if the leading coefficient is positive, again, we say the parabola opens up. This is a repeat. We've had this before. So it looks like this. And what do I mean by A is positive? That would be something like y equals x squared plus 4, because there's a positive in front of this x squared. Or it'd look like y equals 10x squared plus 3x minus 6. Both of those have a positive in front of the x squared, and it causes their graphs or their parabolas to open up. All right, and let's just review from yesterday one other thing. The fact that this is a 1 and this is a 10 out front affects also how thick that U is going to be. Remember, this affects the movement on the y-axis, which is this up-down axis, not the x, because it says y equals. So what happens is it gets stretched to 10 times its height. So that second one, if I were to graph it, I got to sneeze. Uh-oh, look out. Oh, I'm so sorry. Anyway. I don't know what that comes across like on a video, but I had to do it or I would have popped open. All right, if the leading coefficient is negative, then the parabola opens down, makes a frown. That would be like y equals negative 2x squared plus 7 or something like that. So then we have what's called the vertex. And the vertex is really important on your parabola because it's what we call the turning point. And I'm going to go have you write that on here. It's the highest point. So go ahead and write that. So let's go draw our 2 basic shapes. When I draw my parabola like this, the turning point is actually the highest it ever gets, and we call it a maximum. But that blue dot right there is called the vertex. When your parabola opens up, that vertex is the lowest it ever gets, or the place where it starts to turn, and it's called a minimum. And that vertex is really important for us, both in physics and in just the algebra of it, because it's the highest point something that gets launched reaches, which is kind of important. And it also affects how far it gets or where it lands. So the line that passes through this vertex is called the axis of symmetry. And what we're going to do is we're going to go lay this out on the card stock so you can draw a nice big picture. We are not going to be concerned with this at this level. It was not in your first semester either. So what we're going to do is take out that square piece of cardstock if you haven't already. And I'm going to go get a blank sheet of paper here. If you didn't get one, pause the video and go grab it. You might even want to grab a couple colored pencils from up there. So what we're going to do is go get some vocabulary down here. I'm going to draw and put this on the top, I would say 2/3 of your cardstock. And let's label our x-axis, and let's label our y-axis. And then what we're going to do is we're going to go put a parabola on there. And I think the one that I would like to put on there is the parabola y equals, and I think we'll do x squared plus 2x minus, let's just say 1. And I'll show you what that looks like. I'll have it on my graphing calculator so you can see it. So if you were to graph that on a graphing calculator, and I'll go put that equation on here. Let's write it right here. Y equals, and we're going to go graph the one, x squared plus 2x minus 1. And let's talk about what we know. First of all, really when you don't see anything in front of this x squared, there's a 1. And because that's positive, I know it's going to make us smile or it's going to open up. And I'm going to go draw that for you. It actually ends up looking, and you don't need to put your tick marks on your graph, but it actually ends up kind of going like this. It bottoms out over here and goes like that if I were to graph it. There's two things we're going to be concerned about today when we are looking at our equations and at our graphs. And one of those is, where is that vertex? We're not going to graph them today. We're just going to use the equations to figure out, well, where is that vertex? First of all, I want you to go put a dot on it. I want you to point at it. And I want you to write vertex. Not only is that called the vertex, but it's also the lowest point. So sometimes that's called a minimum. So our concern is, where is that? Because when we graph it, we really need to know where to start turning our pencils, because I could go up, 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 and if nobody tells me where to start turning, I'll go up forever. So that vertex is the most important point to find. And you might say, well, can't I just go graph it and look at it? And the answer is sometimes, but usually you can't. So there's a formula that we use. So keep this on the cardstock, and I'm going to go back to the notes on the green sheet of paper. So you kind of got to have both running at the same time. In order for you to find that vertex, first thing you have to do is find what we call the axis of symmetry. So let's go ahead and circle those and go back to your cardstock. The axis of symmetry is this invisible line. It's kind of like your spinal column that splits your body, or that splits the parabola into two symmetrically equal halves. It's this green line, and I want you to stop and I want you to label this. This is what we call the axis of symmetry. And it's really important because the vertex has to live on the axis of symmetry. If you put this in the kind of context of your body, the axis of symmetry is your spinal column, and let's say the vertex is your belly button. It's on there. So if I could find where the axis of symmetry is, I would at least know the x coordinate of my point. Because see, right over here is how far over I go to get to that axis of symmetry on the x-axis. So if I knew what the equation or how far over that was, I would kind of know where my vertex is. Well, how do I find that? You might say, well, LaRute, it looks like it's 1 to the left, so it's at -1. And I'd say, well, no, maybe it's -1.111. How do you know? Here's how you know for sure. It is the line where all the x's equal the same thing. All these are the same amount to the left. No matter where I go on this line, x is the same thing. I'm maybe 1 to the left or 2 to the left. To find it, what we do is we do the opposite of b over twice 2 times a. And you might say, well, that's great, but what are b and what are a? So let's go talk about that. They are the numbers up here in the quadratic function. So a is this first one, b is this second one, and c is this third one. And we're going to be writing them out. We're going to say for this one, A equals 1, because that's what's in front of x squared. B equals positive 2, because that's what's in front of x. And C is equal to a minus 1, because that's what's hanging on the tail end there. So when I figure out where my axis of symmetry is, I do the opposite of B. So I do the opposite of 2 over 2 times A. And then I do the arithmetic and I get negative 2 over 2, which equals negative 1. So I would say my axis of symmetry is x equals negative 1. It's kind of like it looked like on my graph. What that means is 1 to the left, 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 1 to the left. This line is where all the x's are negative 1. So let's go back for a moment to the green sheet. It says to find the vertex and the axis of symmetry, put the quadratic in what we call standard form. What that means is that if it was all jumbled up like this, make sure you put your squared term first so that you can get your A, B, and C all in a row. That's all that means. It says identify what's A, what's B, what's C. And then it says, I actually do this one next. I like to figure out my axis of symmetry first, and then I go do step 4. My axis of symmetry is located at x equals the opposite of b over 2a. For this one up here, I would do the opposite of b over 2 times a. And that would tell me where my axis of symmetry is located. Now let's talk about the vertex. All right, let's go back here. So we've got this all laid out on the cardstock so you can kind of work with that. Now next up, this is what I know about my vertex right now. I know that it lives on the axis of symmetry. So I know that I would go 1 to the left to get there. I get to just dump that x value in. Again, where did that negative 1 come from? Negative b over 2a. Put that in a box, star it, maybe go grab a highlighter and highlight it, because that you need to know. The problem is, how do I know where the vertex is as far as the y value? Because I know it's 1 to the left, but I don't know how far down or up to go. And you might say, well, Rude, it looks like it's maybe 2 down, and you can't go by looks. Here's how you decide that. All right, let's go back. So this is what I know. The equation I'm working with is the equation, let's go see, I forgot it, x squared plus 2x minus 1. So I'm going to write that down. Y equals x squared plus 2x minus 1. I did negative b over 2a, and I got a negative 1. What that means is my vertex is somewhere on that axis of symmetry. Your belly button's on your spine. The problem is I have to figure out how far up or down to go. I need to know what is this y coordinate, and here's the kicker. You plug the x value into the equation. So you say y is equal to the x's squared plus twice the x minus 1. And everywhere you wrote that empty slot, you put in a negative 1. And then you have to go do some arithmetic or use a calculator. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2. So when I go clean this up, I've got 1, down 2 to negative 1, down 1 more to negative 2. And that's where my vertex sits. All right, so let's go back one more time, and then what I'll do is talk you through the first one on the back side of the green sheet. So the vertex has the x coordinate of negative b over 2a, and to find the y, you just plug x in. Seems kind of easy. Well, there's 4 on the back of that sheet, and there's only 4 because you're going to have to get all 4 right. We are going to go do letter A together. So flip the green sheet over. All we're going to practice doing is those top four. All right, we are simply going to identify A, B, and C, find the axis of symmetry, and find the vertex. So I'm on the green sheet, letter A, where it says y equals negative 2x squared plus 4x minus 9. Before we can learn how to graph them entirely, we need to make sure we get that spinal column aligned, and we need to make sure we get the vertex or the belly button on it. So we're not graphing yet, we're just kind of baby steps. So on the back of your sheet, it says you need to identify A, B, and C before you are allowed to begin. A is what's in front of the x squared, B is what's in front of the x, C is this constant tailing at the end, and it's not actually a plus 9, it's a minus 9. So now we've got all our key players. To find the vertex and the axis of symmetry, I use this formula, and you need to write it down when you're using it, or I'll be sending you back. You are only doing 3 problems for this, B, C, and D on your own, and here's the work I need to see. I need to see you writing the formula every time so it gets in your brain. I do the opposite of B over 2 times A. So I go up and I grab B, and I take the opposite of B. Then I go grab A, and I do 2 times A. I clean up the fraction. Negative over a negative gives me a positive. Right now, what I would do is there's 2 things we're looking for. The vertex, it says, and it's got a little semicolon, a colon with an empty slot. And we're also looking for our axis of symmetry. And again, I'm on letter A on the back of the green sheet that you just took notes on. The axis of symmetry I now know. It's the line where all the x's equal 1. So you write x equals 1. You don't just write 1, you write x equals 1. The vertex lives on there. So what I know is the x value on the vertex is a 1. I do these in reverse order. I think it's easier. Now, the only thing is figuring out what is the y value. And this is where I call it just plug and chug. In order for you to find that y value, and this is the work I'll need to see, there's lots of space in between where you identified your A, your B, and your C, and where you have to write down what the vertex is. So I'm going to put a little bit more space in here. So the vertex I know is at 1 comma, because I got a 1, 1 comma what? Well, you plug and chug. You might say, what does that mean? This tells me what the y's are. It says y is equal to negative 2 times x squared plus 4 times x minus 9, and I need to see that written out. And everywhere you put those placeholders for the x, you're going to shove in that value of 1. And you're going to do the arithmetic either in your head or on a calculator. 1 squared is 1. 4 times 1 is 4. Going left to right, this would be negative 2. Up 4 to 2. Down 9 to negative 7. I suggest if you have problems with that, use a calculator for these. It's perfectly legal for you to do that. And I get 1, negative 7. So your task is to do letters B, C, and D. But I am going to send you back until they're perfect, because this isn't about quantity, this is about quality. So if you need to watch the notes again to do those correctly, you ought to do that. Peace out, Girl Scout. For this section, we'll grab a sheet of notes that's not the Cornell note sheet. It'll be tan, and it'll say Notes 2.4 on it. So instead of using one of those blank note sheets, go grab one that looks like this. On the top, it says Notes 2.4. With all the graphing here, it's easier for us to take notes on this sheet directly. So we're going to be doing some graphing, and I'm going to show you how to use your graphing calculator and how I want you to do it by hand. So the first thing you need to do in your graphing is identify the A, the B, and the C. So I'm going to write this as y equals ax squared plus, there is no x term, which means it was a 0x. So when we write it in what we call standard form, we've got an A that's 1, a B that's 0 because the x term is missing, and a C that's minus 1. And when we're graphing, the very first thing we need to do, we don't need to find, we're going to cross that off, by the way, in all of them. That's just an Algebra 2 concept, finding those roots. But what we're going to do is, first of all, find our axis of symmetry and our vertex. And remember, that's a formula that's going to need to be memorized, that you do the opposite of B over 2 times A. And when we do the opposite of B, well, B is a 0, and 0 is 0 no matter what. So we've got 0 over 2 times A. And 0 divided by anything is 0. And that's always the case. When that B term is missing, our axis of symmetry is at x equals 0. And that's actually this axis right here. This is the y-axis, but it's where all the x's equal 0, like 0, 1, 0, 2, 0, 3, 0, negative 1. And what I need to do is figure out where my vertex is on there. Well, to do that, I've got a big old giant eraser here, so in order to figure out where the vertex is, what I need to do is realize that it lives on that axis of symmetry. Somewhere on here is my vertex at 0 something. I just need to figure out 0 what. And we did that in the last section of notes. To figure that out, I need to go plug 0 in to the equation for x. So I'd say y is equal to 0 squared minus 1, which is a negative 1. What that means is my vertex is this one right here. So my vertex is 0, negative 1. And I like to put that in the center of my chart. And then what we do to graph it is we need some more points. So I like to head to the right of the vertex. And then I reflect them over to get the answers to the left of the vertex. Because of that axis of symmetry right there, I'm just going to go to the right, and then from there, I'll reflect them over. So what I do is I rewrite my y equals, I'm going to write this right here, y is equal to x squared minus 1. And for this, I'm putting a 1 in for x. So my y will equal 1 squared minus 1, which is 0. So I'm going to put a 0 in here, but then I get to steal 1 over here because of that symmetry. I don't even have to replug that in. The next one I'm going to put in is a 2 for x. I'm going to do 2 squared minus 1, which is 4 minus 1, or 3. And I go 1 over, 3 up, and then I get to steal negative 1 over, 3 up. And you'll notice that my parabola is opening up because that lead A is positive. So there's the first graph. Now let's go do another one. All right, so for the next one, again, I identify my A, negative 1, my B, which is 4, and my C, which is negative 4. I use my formula x is equal to the opposite of B over 2 times A. The opposite of B will be negative 4. 2 times A will be a negative 2. So I have a negative 4 over a negative 2. A negative over a negative is a positive. So my axis of symmetry is at x equals 2. And I'm going to go put that on here. So I go on my x-axis and I go over to 2. And I put my axis of symmetry. This is that spinal column that's going to split my parabola into 2 equal pieces. Now what I need to do is find where to put my vertex on there. Well, I know it's somewhere on there. It's 2 over, but I don't know how far up or down to go. So in order to figure that out, I have to go back to my formula, and I have to say that the y there will equal negative 2 squared plus 4 times 2 minus 4. And remember, we're thinking of it as this. So that negative's out front, which will give me a negative 4 plus 8, or maybe we have to go use a calculator, minus 4. And what that gives me is a 0 when I add that up. So I know that my vertex is actually right here at 2, 0. So what I like to do is I put that in the center of my chart. I'm going to go 1, 2 to the right, and then I'm going to steal those when I go 2 to the left because I've got that symmetry going right through here. So again, to get those ones that come up next, whoops, move that a little too far. And then I'll go show you on a calculator how you can let your calculator help you as well. For me to figure out this y value, I have to go back to the equation that y is equal to negative x squared, right here, plus 4 times x minus 4. But this time I'm putting a 3 in there. So I'd have a negative 3 times 3 is 9 plus 4 times 3 minus 4, which is going to give me a negative 1 if I do that correctly. So what I have is 3, negative 1, and then I get to steal it symmetrically. So I'm going to go plot those. 3, negative 1, and 1, negative 1. Now I'm going to go put a 4 in. Let's go over here. And I'm going to have y is equal to negative x squared plus 4 times x minus 4. But now in that placeholder, I'm putting in a 4. And if you're wondering where that equation is coming from, it's right here. It tells you what the y's are. So I'm just removing that x and putting in a set of parentheses. 4 times 4 is 16, and there's a negative out front, plus 4 times 4 is 16, minus 4. So I end up with a negative 4 when I add that up. So I've got 4, negative 4, and then I get to steal one over here. So I've got 4, negative 4, and 0, negative 4. I'm going to go up and down, and you'll notice that it's opening down and understand why. It's because it's leading in that negative. Well, now let's go take a look at that one on the graphing calculator, just in case you would like to have some practice working your graphing calculator. So when you go to your graphing calculator, I'm going to hit second quit. If ever it's on a screen that you don't particularly like, I'm going to hit clear to get a blank sheet of paper. When we graph, we hit the y equals button, and I'm going to go do that one we just did. It was, I'm going to move this up a little bit. Why won't it move up? Let me see if I can move it from down here. Just a second, I'm going to go grab a hold of that on my computer so I can move that calculator up a little bit so you can see it a little better. It won't let me move it. Just a second. Well, here, I'm going to have to, I need to move it so I can get to the negative that's on the bottom there, and I'm not able to scoot this over. I wonder if it'll let me click on it anyway. The negative is right here. Yes, all right, I was able to click on it anyway. So it was negative x squared, and I'm doing that example that we just did. I'm just going to show you how to use a graphing calculator if you'd have one and you'd like to use it. It was negative x squared plus 4x, and then it was minus 4. And what I do is I can go make my calculator actually make a table, and it can also graph it. So if you see above graph there it says table, if I hit second table, it gives me a little table of values here, and I can see where the symmetry is. Kind of take a look. The parabola is going up, 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 up. And again, I'm looking over here actually at the y's. See that symmetry right there? And that means this is the vertex, and that's what we got. We had it at 2, 1, and then we put in a 3, and then we put in a 4. And then you can symmetrically steal them backwards. So it works out kind of slick that you can see that where that vertex is right off your table. And it's right here where you can see that symmetry happening above it and below it. And if you hit graph, the graphing calculator will graph it for you. It'll be nice and blue. It looks just like the one I did by hand. So you have to know how to do them by hand, but it's always nice to check them on a graphing calculator if you have one. So our next example, we're going to do two more. And our next one will be the graph of x squared plus 3. So right here with the graph of x squared plus 3, again, I'm going to rewrite it so I can see my a, my 1x squared, my b, which is missing, and my c. A is 1, b is 0, c is 3. To get the vertex and the axis of symmetry, I always use opposite of b over twice a. The opposite of b would be 0. 2a would be 2 times 1, and 0 divided by anything is 0. So I have my axis of symmetry as x equals 0. It's right here where all the x's. Let's go draw it, do it nice and dotted. It's actually the y-axis. My vertex lives on there, so I get to just dump that x value in. To figure out the y value, I go and I plug it right in for x, and I say it's 0 squared, bump it up, 3. So at 0, 3 is my vertex. We don't do the roots. We know it's going to open up because of that positive. We go put our vertex right smack in the middle. We go 1, 2 to the right, and then we go 2 back. We're going to steal the negative ones after we get the positives. So for this one, when x is equal to 1, we'd have y equals 1 squared plus 3, which is a 4. So we'd have 1 comma 4. Let's go plot it. 1 over, 4 up, and then I get to steal the one that I get with symmetry. For this one, I get y is equal to 2 squared plus 3. 2 squared is 4, plus 3 is 7. And then I get to steal this one over here by using symmetry. So I go 2 over and 7 up, and then I get to get negative 2 and 7 up. I connect them with that nice U smile shape, and it's done. So one last one here, letter D. And I would suggest maybe you pause this and go try to do this one on your own, but I'm going to take you through it right now. But you might want to pause it and see if you can do it on your own. First of all, we're not doing roots. Second of all, it's going to open up because it leads in a positive 2. It's got an A of 2, a B of 8, and a missing C, which means it must have been a 0. In order to get our vertex and our axis of symmetry, we use our formula that says we take the opposite of the b term over twice the a term. So we do the opposite of 8 over 2 times 2, which gives us the opposite of 8 over 4. A negative over a positive gives us a negative. So I've got my axis of symmetry over at x equals negative 2. And make sure you put that x equals on there. I will send you back to fix that on your worksheet if you do not do that. So here's my splitter. X equals negative 2. I can even go put that right here. My vertex needs to live on there. So my vertex has an x value of negative 2. Well, what's its y value? Let's go see. This tells me how to get the y's. I do 2 times the y squared x squared plus 8 times the x. And I'm going to put in a negative 2. When I do that, I get 2 times 4 plus negative 16. That'd be 8 minus 16, which would give me a negative 8. So my vertex is way down at negative 2, negative 8. Then I'm going to go to the right to negative 1, and then to the right to 0. And I'm going to use symmetry to go back 1 and back 1. So I'm going to go plug a negative 1 in next. To y is equal to 2 times x squared plus 8 times x. I'm going to put in a -1. You can use your calculator. It's quicker if you do it by hand though. And when I do that, I get 2 minus 8, which is a -6. A little arithmetic going in on that one, which means I get to steal this one. And maybe I'll go plot it right now. -1, -6, and -3, -6. When I put in a 0, that's nice because putting in a 0 just wipes the whole thing out. I get y is equal to 2 times 0 squared plus 8 times 0, which is just 0. So I next have to go through the origin of 0, 0, and then I steal that with symmetry. Remember, this is that spinal column, and your vertex lives on there. So I go to 0, 0, and then I go over here. And then I make my parabola. Notice it's opening up because of that 2, and it's kind of narrow because it gets stretched to twice its normal height. And so the next worksheet that you're going to be doing is worksheet number 4. It is salmon colored. You might want to do one and bring it up and have me check it before you do all of them because this is a tricky section. Have a good one.